Our first lesson in Chapter 8 is on the real number system, and we really want to ask ourselves the question, what's the difference between rational and irrational numbers? What is the difference between rational and irrational numbers? So I'm going to give you notes just like we would in class so you can follow along and write your own, and then I'll post a finished copy to our Google Classroom as well. We also want to know what are some examples of each one. So we're going to talk about the difference between all the different types of real numbers. So the real number system is made up of both rational and irrational numbers. So the real number system is made up of rational, I'm going to underline that, and irrational numbers. So we're going to talk about our rational numbers first, because rational numbers have a lot of different characteristics on them. So rational numbers can be fractions or decimals. They can be expressed as a ratio of two integers. And all that means is it's a fraction. So let's write some examples down. So one example of a rational number would be 0.25. So that's a rational number because it has an ending point. It's a decimal that ends. 0.25 can also be written as 25 over 100. And that's what it means to say that it's expressed as a ratio. So ratio is comparing two numbers or two integers. So 25 over 100, oops, can't see that, sorry. 25 over 100 is a ratio, and these are the same thing. So both of these are rational. This can also be reduced to 1/4. So 0.25 can become 25 over 100, which reduces to 1/4. And both of those, we have a decimal and a fraction, and we can find a specific answer for that. Another type of rational number is a repeating decimal. So we have 0.3 repeating with the line over it. And that's the same thing as 1/3. So because that decimal can be changed into a fraction, it is a rational number. So we actually have 4 different types of rational numbers that kind of go under that umbrella. So we have types of rational numbers. The first type are the natural numbers. Our natural numbers can also be referred to as counting numbers. So if you think of counting numbers, we have 1, 2, 3, 4. They're what you learned when you first learned to count. So our examples are 1, 2, 3, 4, and then it goes on. You can continue counting. It does not include zeros, so not 0. The second type of rational numbers are whole numbers. Whole numbers are your natural numbers so your counting numbers, plus 0. So the only thing different between whole numbers and natural numbers is that it includes 0. So for our example, we're going to have 0, 1, 2, 3, and so on. And it'll continue from there. The third type of rational numbers are integers. Integers are what we normally use in this math class and in Math 7. They are your positive and negative numbers. But these are positive and negative whole numbers, so they are not fractions or decimals. So we're going to write that. No fractions or decimals. So your examples for rational numbers would be, let's see, you could have negative 1/4. Oh wait, that's not right, because I just said it can't be a fraction. I was looking ahead. Okay, so it could be negative 4. Let's try that. Negative 3, negative 2. So we could just go down the number line. Negative 1, 0, 1, 2, 3, and it would go on from there. So our line is almost like a number line. It continues in the positive direction. It continues in the negative direction. Okay. For the last type, our true rational numbers includes all of these plus, let's go ahead and write that, rational numbers. So the entire whole thing of rational numbers, all of them, is going to include your fractions and decimals that can be turned into fractions, like I showed you up here. Okay, so they're decimals that can be turned into fractions. So let's try that again. So our example would be what I started to write up here. Negative 1/4 would be a rational number. I realized I forgot this. Rational number. If we had a decimal, let's say 32.6. So it's a decimal, but it does not go on forever. It stops at 0.6. So we could write this as 6/10 as a fraction. Another fraction 4/5 would be another rational number there. Okay, so these are all of our different types of rational numbers. Now the only thing left over that we haven't talked about really are decimals that repeat forever. And that is our other type of number. So that is going to be our irrational numbers. So irrational numbers cannot be expressed as a ratio of two integers. Basically, it's a fraction. They cannot be written as a fraction. So these are going to include never-ending decimals that do not repeat. So for our example, a very famous irrational number, we used it in our volume unit, was pi. So pi is a number that goes on forever. It does not stop. Now, most of the time we round it, but the true number of pi is 3.141596, and then it continues. There's other digits that never repeat. So it goes on and on forever. And it does not repeat. So we cannot change this into an ending decimal. That's what we're looking for, an ending decimal. Another type that we're going to be looking at this unit is the square root of 2. The square root of 2 is an irrational number because it does not have an ending point to it. So it actually ends up being 1.4142135, and then it continues on. There's lots more numbers after that. So irrational numbers are different from rational because they go on forever. They cannot be expressed as a true fraction, where all of the other types of numbers up here, natural, whole, integers, and rational numbers, can.